Alright, in this video I plan to demonstrate how to construct a line graph. So I've got start with my graph paper here, and I also start with my data. So here's the graph I'm going to make, relative reactivity versus pH. And above here you can see what the graph should look like when I'm finished. So first we need to set up our x and y axes on our graph paper. So the first thing I want to do is find my origin. I want to make sure I leave enough space between my x-axis and the bottom of my paper and my y-axis and the side of my paper. So I usually go up about 5 and then over about 5. And that leaves me where I put this dot here. So then I take my ruler and a pencil or whatever writing utensil you're using and construct your axes. I'm going to make sure they're nice and straight and that they're right there on the blue lines on your graph. They should extend all the way to the top and all the way to the side. With this graph here, I have relative reactivity and pH. I'm going to put my pH on the x-axis and relative reactivity on the y-axis, because pH is what we're changing. It's an independent variable, and the relative reactivity is what's going to change. So I'm going to go ahead and label my x and y axes here. pH, and I don't put the label right next to the line I drew because I got to put some numbers there before we continue. Right. I can go ahead and put a title. The title was already given to me in my assignment. This is trypsin activity. So we're seeing how this trypsin reacts at different pHs. Okay, so I got that ready. The next thing I want to do is number my axes. And if you know anything about the origin, you know this point right here is 0 on the x-axis, and it's also 0 on the y-axis. Another thing that I like to do when I graph, since this is a line graph and not a bar graph, I need to make sure all of my points are on the actual line. So I go through, kind of make little hash marks on all the blue lines here. While I'm doing this, you can probably fast forward the video. Okay, while I did this, I counted how many spaces I have. On my x-axis, I have 38 lines, and my y-axis, I have 28. Now, when I number my axes, I want to use my space up, so I'm going to look at the data that's provided to me. My relative reactivity has to go from 0 to 60. My pH has to go from 0 to 12. If I know that my relative reactivity is on my y-axis and I have 28 boxes here and I have to go to 60, I've kind of done the math, and there's going to be a little left over, but if I do every 2, or if I go by 2s, like 2, 4, 6, 8, I'm not going to get far enough, but if I go by 3s, I can get far enough. There's going to be extra space. So I'm going to go by 3s on my x or y axis. And then with my pH, there's 28 lines, and I have to go to 12. That again, I have to do about 3 to use up my space. So every box, actually, I can go every third box will be 1 to do it that way. And how I got the 3s is just simple division. So I'm going to go through and number these. Use a different marker so I can fit it all in. So here I have to make sure they're evenly spaced. So 0, and then I go 1, 2, 3. That's going to be 1. 1, 2, 3, 2. 1, 2, 3, 3. 1, 2, 3, 4. 1, 2, 3, 5, and so on. It's important you don't, whoops, see what I just did? Don't make any mistakes or you'll be penalized on your grade for the assignment. And also notice that my number's right on the lines. Okay, and then for my relative reactivity, since I have to go to 60, I'm going to go by threes. So this tests whether or not I can multiply by 3 or count by threes. I'm already struggling. Okay, and I'm going to stop there because I know I don't have to go any further. But I could have stopped at 60. Okay, the next thing I do is plot my points. And so here's my y's and my x's. So I have 0, 0. So I go ahead and plot a point right at 0, 0. The next one is 0.5 and 1. So it's pH of 1 and 0.5. That's going to be really close to my axis there. And then I just go through here, 1 and 2. I have 3 and 3, 4 and 4, 5 and 5. Then it skips up 10, 6. 47. Some people do well if they draw a line. Like if I know 40 is about right here, they might draw a line over here and then up from 7. I just kind of eyeball it a little bit. 108. Whoa. Houston, we have a problem. You know what I didn't do? I didn't look at my values right here. That would probably been smart to do. So my values actually go all the way to 100. So I made a mistake. So assuming I didn't make a mistake, you just go ahead and plot the rest of the points here. I'm going to go ahead and make up some stuff for the sake of time. Okay, I have some points plotted. And the last part you do with your line graph is connect the dots with a ruler. Alright, then you might be asked to go a little bit further and analyze the graph. And one question might be, when is trypsin the most reactive? Well, it's the most reactive when it's at its highest peak. So this point right here. And that's at a pH of 8. Trypsin is most reactive at a pH of 8. There's a big peak between 6 and 8 is when it starts to kind of get most reactive.